Hello, my name is Liddle of Pacer International. What I want to show you today is how to use the Axetris Infrared source in your applications. Here we see the output from the Axetris driver board into the infrared source. This is set on pulse voltage mode, and you can see the voltage pulses going into the source. Now we can change the mark space ratio and the frequency of those pulses. And we just went from 2 Hz to 10 Hz. And we can also change the amplitude. So we can reduce the amplitude from 8 to 5 volts. So although we get a theoretical picture on our software, we can also be sure that in real life, this is what is driving the infrared source. The Axetris infrared source is based on a silicon chip using advanced microstructure fabrication technologies. It consists of a thin film resistor supported on a thermally and electrically insulated membrane. The heating relies on the Joule effect in the microfilament, and the low thermal mass of the supporting membrane structure permits it to heat and cool with a very short time constant, around 11 milliseconds and 17 milliseconds respectively. This allows for a fast direct modulation of the emitted infrared light. A unique patented technology by Axetris allows manufacturing of a highly reliable modulated infrared source with a true black body characteristic and a very high emissivity. Emissivity higher than 0.9 is achieved for wavelengths up to 15 microns. The emissivity of the infrared microfilament is enhanced by creating a random surface structure, as can be seen. These are two typical Axetris infrared sources. One is the basic CAN TO5 and the other is the reflector type, which allows for a much smaller spot size. The Axetris infrared source is a thermal black body source. It has broadband infrared emissions, electronically pulsed with no moving parts. It's fast heating and cooling with a wide modulation frequency. It has low power consumption but has long-term stability. It comes in a compact TO39 can with 3 pins. The infrared source can have many different windows, such as barium fluoride, calcium fluoride, sapphire, zinc selenide, germanium and coated germanium. So why would you use the Axetris infrared source? The infrared source gives out a wavelength from 2 microns all the way down to 16, even 20 microns. This is essential if you're looking at gas detection with long wavelength absorption gases and medical applications. The first graph shows how the resistance of the infrared source increases as it heats up. It's key to make sure that when you're driving the infrared source that the electrical power is kept at the most positive level. This would be around about 450 milliwatts, as can be seen on this graph. The resistance increases, meaning that the current in the infrared source will rush in at the beginning and then reduce down. This is shown on the waveforms following. However, because the time constant of the infrared source is so small, it can be modulated well up to 100 Hz. Care must be taken when driving the infrared source at maximum power, as the heat can be conducted down into the metal can, and we can reach temperatures of 50 or 60 degrees C.